Today we study the calculus 1. The topic is local extrema and extrema on open intervals. We have studied global maximum values on the given domain. What is our global maximum? Means the highest market in your school. What means local? Means local maximum value or relative maximum value. How to get it? So now look at, for example, what is the local maximum value in the following figure? Look at the figure. Yes, y equals fx, changeable. Who can tell me what are our local maximum value or minimum value? Get it, x1 minimum, corresponding x2 maximum, x4, x5. These 2 points are our corresponding maximum or minimum values. We can find in the special points corresponding tangent line equals what? As horizontal lines, means corresponding the slopes are zeros. How to get it? So now look at this special point may be here. Look at the definition of local extrema. Let S, the domain of function f, contain the point C. Case 1. Fc is a local maximum value of f if there is an interval from A to B. It is our open interval. Continue C such that Fc is the maximum value of f on the intersection interval from A to B intersection given domain S, means local maximum value. Similar meaning, Fc is our local minimum value of f if there is an interval AB containing C such that Fc is the minimum value in the interval AB intersection domain S, local minimum value. Fc is local extreme value of f if it is either a local maximum or local minimum, means our local extreme value. Try to understand. Means global maximum value means the highest market in your school. Local means highest market in your class. So now look at the theorem of local extrema. The first derivative test. Look at the theorem name. First derivative means using the first derivative signs. Let f be continuous on an open interval AB that contains a critical point C. If f prime x less than 0 for x in AC, corresponding f prime x less than 0 for all x in CB, and then Fc is a local maximum value of f. After that, we can see figure 1. Now look at the case 2. F prime x less than 0 for all x in AC, and f prime x less than 0 for all x in CB, and then Fc is a local minimum value. This means f prime less than 0 and then less than 0. At this time, it's our local minimum value. F prime x has the same signs, means both are positive or both are negative on both sides of C, and then Fc is not a local extreme value of f. Pay attention to the key words. Less than 0, less than 0, or less than 0, less than 0. At this time, it is our local extreme. Otherwise, has the same signs, maybe positive, maybe negative. At this time, it is not our local extreme value. So now look at the figure. from AC positive, from CB negative, at this time it is our local maximum value. Corresponding, look at figure 2. From AC negative sign, from CB positive sign, at this time it is our local minimum. A local extreme value otherwise have the same signs. Positive sign, it is not a local extreme value. Negative sign, not a local extreme value. Means not a local extreme value. Why? Because they have the same signs, maybe positive sign, maybe negative sign. At this time, not a local extreme values. Why these two? Positive means increasing, decreasing, maximum. Decreasing, increasing, minimum value. So now look at the theorem of local extreme, the second derivative test. Look at the name. Second derivative means using double prime. So our condition means that f prime and double prime exist. Means first derivative, the second derivative exist at every point in an open interval AB containing point C, and suppose that f prime C equals 0. Pay attention to the given condition. F prime C equals 0 means C is our stationary point. At this time, we will consider the double prime. How to determine the local extrema? If case 1, f double prime C less than 0, and then Fc is a local maximum value. Pay attention to less than 0 and then maximum value. Case 2, if f double prime larger than 0, at this time Fc is a local minimum value. Larger than 0, minimum value. Try to understand the theorem. Pay attention to the given condition f prime C equals 0. Under the condition C is our stationary point, and then according to the signs of double prime, determine which values is our local maximum or minimum values. So, how to remember? It is a theorem need our to prove. So now we prove the case 1. Case 1, the condition means f double prime C less than 0. What means double prime? The second derivative. How to get from the first? F double prime C equals limit f prime x minus f prime C over x minus C. It's our the definition of limit. Write it f prime C. Why? The given condition, our stationary point, so minus 0 over x minus C. Given condition, less than 0. Less than 0, if x doesn't equal C, means corresponding this expression less than 0. Why? According to the meaning of limit, we can get f from x times x minus C, the product of the two terms less than 0. We can get if x less than C means x minus C less than 0. At this time, f prime less than 0. Corresponding x larger than C, f prime less than 0. So, from A to C positive, C to B negative. This time it is our Fc is a local maximum value. In similar way, try to do proof the case 2. So work by yourself. Try to prove case 2. Using our theorems to finish our examples. Now look at example 1. If fx equals x plus 1 cube times x minus 1 2 over 3. Use the first derivative test to identify the local extrema. What is the first derivative test? Yes, f first prime. Get the corresponding to signs. What signs? The signs between A and C and then C and B. According to the signs determine it is our local or not local extrema. So the first is to do the f prime. F prime x equals 3 times bracket x plus 1 squared times something plus another prime. It's the first derivative. How to do? Yes, get the corresponding common factor. It is our common factor taken out. Together we can get another expression. Pay attention to this expression. How to get corresponding the f prime equals 0 or does not exist? Look at the stationary point means this term equals 0. This term equals 0. We can get the point x equals minus 1 or x equals 7 over 11. And then this term, pay attention to this term equals 0. We can get our singular point. Singular point means x equals 1. Together 1, 2, 3. 3 points. So we can get 3 points, get the corresponding the table. Remember, stationary points and singular points. And from f prime, we can get the corresponding table. 1, 2, 3. 3 points. The original domain is divided by 4 intervals, so we can get x. Okay, minus infinity to minus 1. Minus 1 is our special point, means stationary point. Minus 1 to 7 over 11. 7 over 11 is another stationary point. And then 7, 11 to 1. 1 is our singular point, from 1 to positive infinity. So 1, 2, 3. 3 points, our original domain is divided by 1, 2, 3, 4. 4 intervals. So now look at corresponding f prime signs according to this expression. X between this interval, f prime corresponding positive. This point 0 corresponding positive 0. Minus means negative. Not exist. Less than 1 at this time positive. How to determine? Yes, consider the signs of the stationary point or singular point. This is increasing. This is increasing. So the point not local extrema. Increasing means the same signs. Together, increasing, decreasing means the point is our maximum, means local maximum value. Positive means increasing, decreasing function, increasing function. So local minimum. We can get our conclusion f at the point 7 over 11 close to 2.2 as a local maximum value, corresponding f1 equals 0 as a local minimum value. Try to understand the example. 4 steps. The first step, get f prime. Second step, try to get the special point. Step 3, making up the table. Consider the special points. Step 4, we will determine the point is our local maximum or minimum point. So now look at example 2. If fx is given 1 over 3 x cubed minus x squared minus 3x plus 4. Use the second derivative test to identify the local extrema. Do you remember the second derivative test? Yes, according to the sign of the double prime. But do you remember the given condition? Under the condition f prime c equals 0, means c is our stationary point. So now look at f prime x. F is given. We can get f prime x equals x squared minus double x minus 3. We can get this formula. X plus 1 times x minus 3. F prime equals 0. We can get two stationary points. One is minus 1. Another is 3. F double prime. What to do? Yes, from here. The first time derivative, the second derivative, means derivative again, prime again, double x minus 2, f double x. We should determine the signs of f double prime. At what point? At the stationary points, means minus 1 and 3. So determine the sign of double prime at minus 1 equals minus 4. Minus 4 less than 0. Do you remember? Less than 0 means local maximum. So f minus 1 is a local maximum value. Less than 0. Similar meaning, we will determine the sign of double prime at the point 3. F double prime at 3 equals 4. 4 is less than 0. So f3 is a local minimum value. Try to understand, according to our stationary point, minus 1 and 3, and the signs of double prime determine local maximum or local minimum values. Now look at example 3. Try to find the local extrema value at 2 this expression. Fx equals x squared minus 6x plus 5 on the given interval, the real number system. How to write it? Yes, the first, we should get the first derivative. F prime x equals double x minus 6. 2 is our common factor taking out, equal to 2 times bracket x minus 3. F prime x equals 0. We can get x equals 3, prime 3 equals 0. 3 is our stationary point. Determine the sign of f double prime. Look at this. F double prime x. From here equals to 2. This means at every point corresponding f the second derivative always equal to, means always is a positive number. So f double prime at every point, of course at 3 point, equal to 2 less than 0. Why we select the point 3, not 30, not 300? Because 3 is our stationary point. We should consider the sign of double prime at point 3. Less than 0, this means f3 is our local minimum value. So our conclusion is f3 is a local minimum value. Remember, local minimum value. So we can get the following summary. The first derivative test, f prime less than 0, and then f prime less than 0 between the different intervals, and then fc is maximum value corresponding less than 0 and less than 0 means local minimum value. Together, if f prime has the same signs, or positive or negative, at this time, fc is not a local extreme value. Summary 2. Try to remember the second derivative test. F first prime, F double prime exists at every point in an open interval AB, the AB containing the point C, and suppose that means under the condition F prime C equals 0. Try to understand. F prime C equals 0 means C is our stationary point. Case 1. F double prime less than 0, corresponding local maximum value. F double prime is less than 0, is local minimum value. So try to remember less than 0, maximum value. Less than 0, minimum value. According to our summary, try to finish the question. Try to find the local extreme value at 2fx. It is a polynomial equals x cubed plus 3x squared minus 24x minus 20. How to do? Yes, find the first derivative. Look at f first derivative equals 3x squared plus 6x minus 24. Get the point, okay? What point? Write this. Equals 3 times x plus 4 times x minus 2. If we write f prime x equals 0, try to get the corresponding points, means obtain the stationary points. How many points? 2 points. One is minus 4, the other is positive 2. We found the two stationary points, and then determine the signs corresponding the stationary points, the double prime. F double prime from this 6x plus 6. We can determine F double prime at the first stationary point minus 4 equals minus 18 less than 0. Less than 0? Remember? Yes. So corresponding the local maximum value is F minus 4. The value is 60. Corresponding determine F double prime at the another stationary point. 2. Determine the sign equals positive 18 less than 0. At this time, the local minimum value F2 equals minus 48. Remember, less than 0, minimum. Less than 0, maximum. So, the class is over. See you next time.